Yeah, for this one, we're really just doing x to the third plus 1 dx. For this one, we're doing u to the third plus 1 dx. For this one, we're doing u to the third plus 1 dx. And I'm sorry, the middle one would be du. So for this one, we just do it like normal. X to the fourth over 4 plus x plus c. This one would be u to the fourth over 4 plus u plus c. But this one, if we're taking it with respect to x, we need to start in terms of x. So we're going to plug in x squared there. So this one would really be the integral of x to the 6th plus 1. Okay, which is x to the 7th over 7 plus x plus c. So my final answers are circled. Does that make sense? Okay. Good. Now we're going to go into substitution in indefinite integrals. We're going to make, how can this make things easier here? What are we going to be substituting, do you think? What other variable have we been using? U. So we're going to basically reverse chain rule. Okay? It's not terrible. So what we're going to do is we're going to look for a function and its derivative inside our integrand here. Okay? So what function do we see that has its integral somewhere? Which one? Inside the integral from sine of x times e to the cosine of x. The derivative, which one is a separate function and which one has its derivative in here? So which one's going to be our original and which one's going to be our derivative? So sine of x is going to be the original and cosine of x is going to be the derivative. That's what we're saying? So let's think about how we would do it. If we have u equals sine of x and u dx is cosine of x, let's see if this helps us. We would then have the integral of u, or I'm sorry, no, u is sine of x, u e to the u dx, and then we've got dx. Does that really help us? Well, we put it back in. That didn't work. Okay. What we're going to be looking for, and I know this is different. Okay. What we're actually going to take as our substitution here, we know the derivative of antiderivative of e to the u, right? So I'm going to say u is equal to the cosine of x. Okay. So du dx is what? Negative sine of x. And this is where we have to start putting things on the inside and the outside of our integrand. Okay, so how can I write this down to make it look like that inside, to replace this inside the integrand here? So I could have the integral of, if I have negative sine of x, I can put a negative on the outside, right? That would make it a net positive. So did I change anything in this problem right now? So I've got negative times negative sine of x times e to the cosine of x dx. Okay. Now I can see that my derivative of cosine is inside there. Okay. So now I'm going to rewrite it in terms of u and du dx. So I'm going to have negative integral of e to the u, and I'm going to just switch these here. Okay, I'm just going to write them in different spots. So I'm going to write the e to the x cosine of x first and the negative sine of x second. So e to the u times du dx dx. Right? Does everybody see that? Okay. Dx over dx. And then I'm left with the integral, negative integral of e to the u du. What is the antiderivative of e to the u? E to the u, right? So my answer is going to be negative. We can't forget about that negative out front. E to the u. What was u? Which was cosine of x. That is the antiderivative of it. There's a negative in there. Negative e to the cosine of x. Let's check that by doing the antiderivative. I'm sorry, by taking the derivative. What would e to the cosine of x be? E to the u, if the derivative of that is e to the u times du dx, right? So negative e cosine of x would be negative e cosine of x times negative sine of x. The two negatives are going to cancel, right? And then I'm just left, if I rewrite them in a different order, sine of x e to the cosine of x. Isn't that what we started with right there? Okay. And that's our substitution. So we have to look for a function and its derivative, and we have to make it into a way that we can take the antiderivative. Okay? It's not easy. Okay, this is different. I know you guys haven't seen this. It's pretty tough when you first start out. Okay, so we need the extra practice here. Now I want you guys to try and think of what would be the easiest function here to take to replace with a u. Okay, and what we can multiply and divide by to cancel things out. What? I just want you guys to help me with this one. How about that? Okay. So which one are we going to want to be the u? Under the radical, probably. Okay. So Dan. Not when we're multiplied there. Just think about it. That'd be like a product rule or something like that. So that's not what we're going to do. We need to do the same idea. We need to substitute u. Something in here needs to become u, and then some part of this needs to be du dx. So what part of this do we see that could be a derivative? On the inside of the square root, I have an x to the third, right? What's the derivative of an x to the third? An x to the second. Okay, 3x to the second, right? So what would the derivative of the inside be? 6x squared. Okay, so what am I missing inside my integrand? No, inside the integrand, like inside just this portion right here. What am I missing from the derivative? The derivative would be 6x squared, right? I have the x squared, I'm missing the 6. So what I have to do is I'm going to bring a 6 in. Okay, how can I counter multiplying the 6? Divide by 6, or multiply by a 1/6. And that would be the same thing, right? Basically, I'm just multiplying by 6 over 6 here. So did I actually change our problem? No, I just multiplied by 1, right? Now, what part is going to become the u? The inside here. 5 plus 2x to the third is going to become a u. Well, no, it's going to be radical u is going to be our thing. So our u is 5 plus 2x to the third, and du dx would then be 6x squared. So I have u and I have my du dx within the problem. Right, so what I'm going to do then is replace those. So I have 1/6 integral of, and I'm going to, again, reorder these. A lot of times the du dx gets put out in front. So I would have the square root of u times du dx dx. Right? Do you see how we get one from that step to these two steps? This is my du dx. And then this is my square root of u. Okay, now what happens with the dx's? They cancel. So I'm left with 1/6 integral of, and what's an easier, I like working with fractions, that's what we normally deal with, right? So u to the 1/2, and then just du. So what would the antiderivative of u to the 1/2 be? Well, what is it? U to the 3/2, but we always have to put it or over 3/2. That's why I always divide by the number. It keeps me from making mistakes. Okay, so the 1/6 is still out in front, and then I've got that plus c. Right? When we divide by a fraction, we flip and multiply. So that's where your 2/3 is coming from. Okay? So I've got 1/6 times 2/3 u to the 3/2 plus c. So I end up with 2 over 18, right? So 1/9 u to the 3/2 plus c.
Today during Magic period, you are all required to attend the course.
That's saying take the antiderivative of u to the 1/2. Yeah. And then we'll replace it with an x in the end here. Okay? So now we're going to replace u to the 3/2 with 5 plus 2x to the 3rds on the inside. So I have 1/9 square root of 5 plus 2x to the 3rd plus c. What is, oh, so throw that square root, right? Sorry, it's 1/9 5 plus 2x to the 3rd raised to the 3/2 plus c. Okay, so we should be able to take the derivative and work backwards on that, right? Okay, for tomorrow, we have a 7.2 My Math Lab up. If there's any with trig, just ignore them right now. Okay, we're going to go over the trig tomorrow. And then we'll go over definite integrals with substitution. Okay? All right, see you tomorrow. Such a quiet class without banana, wasn't it? Yeah.